Okay, so good evening, everybody, officially. My project for my honors thesis was on the diversity of true crabs in the St. Lucia Estuary. And I'm sure most of you know about the St. Lucia Estuary, but just a bit of background. It is the largest estuarine lake system in Africa, covering an area of about 350 kilometers squared, and it's subject to prolonged mouth closure as well as stochastic flood and drought events. And all of this leads to large-scale periodic fluctuations in physico-chemical characteristics, the most well-studied or notable being fluctuations in salinity. Then, in addition to this, you have anthropogenic disturbances around the lake, and urban and agricultural developments began around the lake, or increased substantially around the lake in the early 1900s, where you had manipulation of the mouth, freshwater abstractions from nearby rivers, and the increase in sugarcane farming and tree plantations as well, I believe. So these lead to regions of hypersalinity, especially in the northern lake and False Bay. Then you've also got freshwater inflow from the Mfolozi River, which enters through the Narrows, and you have sand dune aquifers on the eastern shore of the South Lake. And this compounds the effect known as the reverse salinity gradient, in which salinity actually increases as one moves away from the mouth. So how does this affect biodiversity? Okay, anthropogenic disturbances reduce water quality, decrease freshwater inflow, and urbanize the natural habitat of many inhabitant species. Then you have fluctuations in salinity which negatively affect biodiversity, with your stenohaline organisms moving out of the area. And in fact, in St. Lucia, a lot of euryhaline organisms are moving out as well. And so currently there is a biodiversity census being carried out in the Simangaliso Wetland Park in conjunction with Ezemvelo KZN Wildlife. So my project forms part of this, and I've chosen to focus on brachyurans. Now, I know that rhinos are very important, but so are crabs. Okay, the ecological importance of brachyurans can be, in terms of food webs, can be summarized into three main aspects. So first, you've got the consumption of organisms at lower trophic levels, such as your smaller gastropods and mollusks, as well as your plants and algae. Then brachyurans are consumed by organisms at higher trophic levels, such as your birds, your fish, and even larger crabs. And in this way, they allow for the flow of energy through these trophic or food webs. Thirdly, they consume, and this is especially important in mangroves, where brachyurans consume detritus, or decaying organic matter. And this allows for the recycling of nutrients, and especially important in oligotrophic environments. You know, it helps with productivity. In terms of the burrowing behavior, you have aeration and oxygenation of mud. And again, here we consider mangroves, where the mud is really dense and thick. And these crab burrows allow for the movement of nutrients and water through the soil in a process known as tidal flushing. So what happens here is, as the tide comes in and moves into these burrows, it takes with it nutrients and water and removes any waste products. And this allows for growth and development of mangrove seedlings. Of course, the burrows also modify sediment topography and the associated microflora structure. Then regarding management, not much work has been done on brachyurans compared to other taxa. And we find a lot of misidentifications and a lot of, people just tend to push them aside. Then we've also had the loss of two prime carcinologists, the one being the late Dr. Owen, who did quite extensive work on the regional endemic we have in St. Lucia, Paratylodiplax, blephariskios. And then also Dr. Winks Emerson, who's moved out of the country many years ago. And we can't seem to get hold of him. So this all leads to what I like to call a messy taxonomy situation. And then how can we manage something we don't fully understand, of course? So the aims and objectives of this study were firstly to investigate changes in brachyuran diversity of the St. Lucia Estuarine Lake, and we did this by comparing present diversity to past records. We also decided to compile an illustrated, annotated identification guide of all brachyurans found in the St. Lucia region, and hopefully this would help managers, decision makers, and even scientists who study these species or work with these species. And then additionally, we just decided to compare the distribution and abundance of 3 key species between past and present records. And for these 3 species, we chose, it's Hymenosoma, CF orbiculare at the top. And we chose the species because it's the only species to once have been recorded throughout the entire system. Then you have Neosarmatium africanum, known to most of you as Neosarmatium maynardtii. The name's been changed. And then, of course, Paratylodiplax, blephariskios, which is the endemic. Okay, so this is our study site. You have False Bay and North Lake, and we sampled 2 points representing False Bay and North Lake. Then for the South Lake, we did a transect across it, as well as Fani's Island and Makagatana. Then we sampled the Narrows and the mouth quite extensively. Lots and lots of literature review. The paper we relied on the most was the one by Millard and Brookhaven, where they talk about the surveys of 1948 and 1964. We also looked at museum records. The Ezekiel Museum in Cape Town was quite helpful, actually. And, of course, your books, your 2 oceans, and guides to the freshwater invertebrates of southern Africa. Then we were communicating with quite a few experts, and here we spoke to Dr. Gavin Goos from SIAB, who's quite good with the freshwater crabs, and then we had to rely on a few international experts due to the lack of expertise in this country. Lots and lots of sampling as well. So we used every possible sampling tool you could think of: shovels, spades, the Ekman grab, netting, and then, of course, the most efficient and terrifying, active search and capture. Okay. For the sake of the checklist, we took dorsal and ventral pictures of all species. Some species that aren't in St. Lucia anymore, we've had to actually locate them from alternate locations, and this is still, I think we're still missing 1 or 2 species, so it's a mission. Okay, so Millard and Brookhaven reported about 26 species in St. Lucia by 1970. And you have a ghost crab, about 5 species of sesamids, 4 fiddler crabs, and even some marine species. By 2012, we had about 12 species, yeah. And you have 3 sesamids, I think 1 fiddler crab. Of course, Silacerata is still there. That doesn't ever leave. You've got a few marine species, although some of them have left as well. But it's not all bad news. We did find some previously unrecorded species, and these included 2 ghost crabs, which haven't been recorded there previously in the literature, as well as Neosarmatium smithii, which is actually very often confused or misidentified as Perissosoma guttatum, as they look exactly the same and literally live in the same burrow. The 2 species live in one burrow. And then, of course, the cherry on top is the new Potomonati species. So we found this in a stream just north of Lister's Point, and we have sent samples to Dr. Gavin Goos as well, who's helping us with the description. In terms of distribution and abundance, you have Paratylodiplax blephariskios, which is endemic to the northern region of KZN, and St. Lucia actually once held one of the 2 largest populations of the species. So you can see in 1948, they occurred all the way up the Narrows to the Imparte River, and were recorded as abundant or common. And then by 2012, we didn't find them at all in the St. Lucia system. We only found them at the Mfolozi back channel. So they've almost moved out of the system and formed a refuge population at the back channel. This is, not bad, because should conditions ever become favorable for them again in the system, they could recolonize the lake. Then with Hymenosoma orbiculare, or CF orbiculare, sorry, it was once found throughout the lake and recorded as rare to common or abundant. And now we found it only at Fani's Island and Catalina Bay. Of course, distribution would fluctuate with salinity as salinity levels rise and drop like crazy in St. Lucia. But at the moment, this is what we found, and it's not looking very good. Okay, with Neosarmatium africanum, it's the only species to not have decreased in distribution. And it is where it always was, right up the Narrows, up till the Mpate River. And you find these in mangroves, in reeds. They're very hardy. They're in very desiccated ecosystems as well. So why is a lower diversity detrimental? Okay. Well, diversity has been linked to ecosystem stability and productivity. So with a low diversity, you have poor maintenance of ecosystems. You have less nutrient recycling, less energy flow, less functional roles being filled as well. Of course, you've got the loss of an important food source. As you've seen, many species actually rely on these brachyurans for as a food source. And then, reduced nutrient cycling and energy flow. Lastly, we considered how could the St. Lucia Mfolozi linkage possibly affect brachyuran diversity. So I'm sure most of you know that they recently joined the Mfolozi and St. Lucia together at the mouth. And I think breaching has occurred, or yes, has occurred. So how does this affect, or how will it affect brachyuran diversity? Well, the first thing we can assume is that conditions or physico-chemical conditions would be a lot more stable than they are or were currently. And this means that a lot of species would be able to once more recolonize the system and inhabit this lake. This is good news. Of course, with the opening to the marine system, you'd have the recruit of new juvenile species, possibly. And then, you could argue, what about alien species? Although this doesn't seem to be much of a problem on the east coast of South Africa. And then lastly, I think I spoke a bit fast, but okay. I just had a bit of a video clip.
You can wait up here for a question. Thank you very much, Nasreen. We'll take, again, one question. I think your drinks are going to be reduced by the time you get there. And as you all know, if you want to drink this evening, you have to name two of the crabs, their scientific name, before you can drink. So.
Okay. Oh, I hate this stupid thing. Okay. Hi. Say again? Oh, sure. I'd be keen. Okay, thanks. Anyone else? Mm-hmm.
Since that didn't appear to be a question, I want to muscle in. From your research, besides the crab diversity, my message is taking home that St. Lucia system is not closed, and that the refuge sites outside of St. Lucia are probably more important than the system itself, because without the refuge areas, with the system fluctuating so much, we should actually be conserving the refuge areas far more than we are doing with the lake. So the question is, am I right?
Well, I agree. You learn about, ecosystem approach to fisheries, and basically what they're saying is that you can't consider one organism or one species, or in this case, one system in isolation, but you have to consider the systems around it and the systems that it interacts with. If, for example, they hadn't conserved the Mfolozi, we wouldn't have that little population of Paratylodiplax. And they would probably be almost extinct or extinct. Yeah, I agree. Okay.
Right, Nasreen, thank you very much. A round of applause as well.